All right, today we are moving on to a new big idea, developing number sense and demonstrating an understanding of multiples and factors and prime and composite numbers, and using that to help us to describe and solve problems in the real world. Our concept for today is going to be demonstrating an understanding of prime and composite numbers. You are going to be looking at lesson 4 in your unit 2. So to start with, we're going to look at the number 23. We're going to have 23 tiles. We can only make one complete rectangle with 23 tiles. And therefore it only has one set of factors, 1 and 23. So we can only make 23 by a 1 and 23 squares long rectangle. This means then it is a prime number. A prime number is a number that is greater than 1, that can only be divided, is only divisible by 1 and itself, or only has 2 factors, 1 and itself. You are familiar with prime numbers from our calendar math already. Suppose now we take 24 tiles. With 24, we can actually make 4 different rectangles. We can have a rectangle that is 1 by 24, 2 by 12, 3 by 8, or 4 by 6. That makes this a composite number because it has more than 2 factors. Or it has at least 3 factors. The factors of 24 are 1 and 24, if we were to make it a factor rainbow, 2 and 12, 3 and 8, and 4 and 6. All right, so there are 2 different strategies used to find factors. For example, here they've used multiplication facts, which they could turn into a factor rainbow. 1 and 40 are factors of 40. 2 and 20 are factors of 40. 4 and 10, oh dear, I'm running out of room. And 5 and 8, I'll just squish those down here, are also factors of 40. Or you could use arrays, just like we do in our calendar math again, or they could be created into rectangles of 1 by 18, 2 by 9, and 3 by 6, meaning that all of these are factors then of 40. Therefore, 40 is a composite number. A few special numbers to note. 1 is not prime and it is not composite. It's what we call a special number. It does not have 2 factors. It only has 1 factor, 1 and itself, which is 1. So it really only has 1 factor, 1, which makes it not prime, not composite. 0 is also not prime or composite. They're 2 numbers that would be considered special. All right, moving along. If we had the factors of 18, so 1, 2, 3, 6, 9, and 18, the factors that are prime numbers here would be 2 and 3, because those are only able to be gotten by 1 times 2 and 1 times 3. The numbers 6, 9, and 18 would all be considered composite numbers, because 6 you can get with 2 and 3, 9, 3 times 3, 18, 2 times 9, 3 times 6, and so on. The number 18, however, itself would also be considered a composite number because it has all of these factors. Every number should have at least two factors, one in itself, other than one, of course. A number with more than two factors is considered a composite number. Go ahead now and try 15 and 57 and 96. Be ready to explain why they are prime or composite. Try it now. All right, let's try it. 15. Did you say it was prime or composite? If you said composite, you are correct. How do we know? We know it's composite because it has the factors 1 and 15, as well as 3 and 5. So there are two ways to get 15. What about 57? Is it prime or composite? Now, to find out if a 57 is prime or composite, I don't automatically know numbers that work into 57. So I'm going to use my calculator for this. And I'm going to try 57 divided by a few numbers. 57 divided by 2. Well, that doesn't work because 2 will not divide into an even number, an odd number evenly, so it's 28.5. Doesn't work. 57 then divided by 3. It's always good to try 2, 3, 5, those kinds of numbers. And 57 divided by 3 does equal evenly. It's actually 19. So that makes this also a composite number. Last one, 96. Again, this is a higher number. I'm going to have a hard time with that one. I'm going to try 96 divided by 2. This is an even number, so it should work. And it equals 48. So this is also a composite number. Let's try 13. Would 13 be a prime or composite number? Take a moment, figure that out. All right, let's take a look. 13. Well, what are the ways that we can make 13? In this case, the only way we can make 13 is 1 and 13, which means this number then is prime. What about numbers like 17? Try that one. All right, let's take a look. Again, 1 and 17 are the only factors for 17, making it prime. Last one. Lastly, let's try 39. Again, 39 is a bit of an odd number. It's a hard one to work with. Because it's an odd number, I would probably try 39 divided by 3 rather than 2. 39 divided by 3 does equal 13, so that means this is a composite number. There should be some generalizations that you can make, and that would be that if it's an even, if it's an even number, it will automatically be what? Well, if it's an even number, we know it can automatically be divided by 2, so that would mean that it is a composite number. Running out of room there. The only number that does not apply to this is the number 2, because the number 2 is actually prime, because it only has two factors, 2 and itself. Generally speaking, odd numbers are tricky because they can be either prime or composite. So you have to check these ones more carefully. I would always divide it by 3, divide it by 5, divide it by 7 to check if you're on the right track or not, whether or not that number is odd, or whether or not that odd number is prime or composite. All right, at this point you are ready to go on to your concept practice. Remember, this is your title, and it is in your textbook, page 61, numbers 2, 5, 8, and 9. Make sure if you have any questions that you come and ask me before you begin. Good luck!